To solve for the ratio between height 1 and height 2 using Newton's second law, we began by expanding out the equation with the force of gravity being the only force acting on the non-rolling roll, and the force of gravity acting downwards on the rolling roll, and the force of tension acting upwards. We solved both equations for acceleration and then used kinematics to find the relationship between acceleration and time, which also included height. Once we had both equations set equal to time, we were able to set them equal to each other to find out at what heights they would land on the ground at the same time. After that, we solved for the ratio to find out what those heights need to be.
We can also calculate the ratio between the heights using conservation of energy, knowing that they both start with gravitational potential energy, the same amount, and one ends with only translational kinetic energy, while the other has both translational and rotational. We can start by finding the times that it takes for both to drop and reach the ground, especially having h in the terms, with the goal being to set the times equal and then using that equation to find the ratio between the heights. So you can just use simple kinematics for the first roll that's not rolling. Second one, you can, what we did was write out generally the I term. We found that from Google and then added in beta for whatever the coefficient was. Um, and then we went through the algebra, found A. With kinematics, we found T, set them equal, and then eventually the beta canceled out and we got the ratio on the bottom right.
We determined that our ratio was about 1.5, and in order to apply that, we started our highest height at 1 meter. After dividing that by the ratio, we were given our second height of about 0.64. In order to actually use that in our situation, as our tape measure only used inches, we converted to inches in order to determine the correct heights that we needed to drop the toilet paper rolls from.
Our height for the rolling roll is 25 and 3/16, and the height for the just dropping roll is 39 and 3/8 inch. Alright, so we have a setup camera right here, and we're about to drop the toilet papers.
So we have one with the little bit opened up, and we're going to tension it like that. We have the other one right here. We're just going to drop it regular. And we have Keith in the back recording.
Yeah, Keith, take the phone. Alright, now we got two cameras. Alright, we're going to drop it on one. So, three, two, one. Pretty good. So, three, two, one. Pretty good. One.